Right, okay, so our next presenter is Nicola Oshinaki. Did I get it right? Okay, so Nicola's going to be talking about learning to audit using data. So taking a step back and actually understanding what data is and how it can facilitate the audit. And how to have those conversations with the business where they give you the data that you need rather than something that they think you want. Okay, so Nicola, thank you. Here you go.
Hello. I must say I breathed a slight sigh of relief when the last presentation covered some of the points that I'm going to be making, because it would have been a bit embarrassing if I completely contradicted what you said, so thank you. Almost good afternoon. So my name is Nicola Oshinaki, and I am the founder of a company called Audit Data Hub, a company I started to provide technology training for auditors new to IT. I'm a practicing IT audit manager with 18 years experience. Well, 18 years industry experience. But before I became an auditor, I graduated as an engineer. So I've used my STEM background in a variety of roles. And over the years, I've really enjoyed using stats and data in different ways, mainly to make my job easier. So moving into audit, it seemed pretty logical to me to continue on that vein. But I quickly found that others weren't on this wavelength, and I was actively discouraged from using data. But we're in exciting times now, and data analytics is now firmly in the spotlight. So, in my opinion, everyone here today, but more specifically, the auditors in the room, should be seen as a trailblazer, and here is why. In 2018, PwC identified that only 13% of internal audit teams worldwide were using data analytics to identify risks. So despite years of talking about the benefits and the choice of new software tools, audit professionals are not utilizing data in significant numbers. So, regardless of your current capability, you were all trailblazers, because by being here, you were actively bucking this trend. Now, I am sure many auditors are quietly hoping this whole data thing will just go away. I hate to be the bearer of bad news, but we are living in a digital age. This data thing is definitely not going away. Last week, I attended the IIA annual conference in London, and the ongoing theme was loud and clear. Audit has to adapt to the rapidly changing digital environment, and data analytics is a key driver. I doubt this news is new to anyone, but for many, although the aim is perfectly clear, the path to get there can just seem impossible. It's easier to simply maintain the status quo. With data analytics, it is always better to start small and deliver something rather than just hope the fad will just disappear. This is not about binning your existing skills. It's about developing new skills which will help to bolster traditional techniques, which together deliver a far superior result. Now, for the experts in the room, some of what I will be saying today may seem obvious from your perspective, so I apologise. But these stats and the chronic shortage of data skills worldwide prove it is not at all obvious to the majority. But beginners have to come out of their comfort zone and learn to work with data. And data experts are really needed to work alongside beginners to help to make this change happen. So this is what I will be covering today to take you nicely into the lunch break. So first is some of the hidden truths to data analytics. Next, we will discuss the importance of data literacy. TSB kindly discussed that today. And finally, I'll walk through some very simple audit examples just to demonstrate the benefit of using data. Hopefully there'll be some time at the end for questions. So let's start with some of the hidden truth to data analytics. The things that can often happen but are rarely spoken about. The first is language. I believe language has the potential to influence some, but strongly dissuade others. It's easy for those with data analytics skills to assume everyone has the same level of knowledge. Technical terms turn to jargon, which is never properly explained, and suddenly everyone has stopped speaking in plain English. So here's one of the many definitions of data analytics: the tools and techniques used to interrogate data to extract useful information which directs you or the target audience actions. So let's start by focusing on the first part, the tools and techniques used to interrogate data. Now, in the reality, data analytics has a scale of complexity, but sometimes the exact same term is used to describe them all. Now, at one end, we have descriptive analytics. These are the techniques which answer the question, what has happened? They are based on historical data and include simple methods like comparing data fields, identifying trends, or calculating total values. Then the complexity starts to increase as you start to move towards big data, analysing large, complex, and unstructured data sets. It's more complex because of the need to use algorithms. Now, to drive this technology, you would require at least some knowledge of computer programming or advanced maths. The complexity increases again as you start moving towards machine learning and AI. Areas often with the greatest focus because they provide the greatest value. But why? Because they suggest what action we should take in the future, not just telling us what has already occurred, essentially helping us avoid the risk altogether. But to drive this technology, you would need a reasonable understanding of computer science. Now, despite the availability of more and more data tools, without understanding the basics, many struggle to utilise them and can lack the confidence to even try. I really want to emphasise to the beginners here today that simple techniques can still add significant value, especially when compared to not using data at all. You definitely do not have to be a data scientist to get involved. Now, moving to the last part of the definition, directs you or the audience actions. The point being, the results you obtain by using data analytics provide the maximum value by enabling a decision or some action. Just the stats alone provide limited value. Again, I'm not suggesting that analytics should completely replace traditional techniques. It's probably as risky to solely rely on sample testing as it is to solely rely on data analytics. These techniques are still needed, but should instead be guided by the insight of data. Now, another language barrier could be the actual term itself, data analytics. Is it possible that the term itself just sounds too complicated? Could this be discouraging auditors? I wonder what would happen if instead we renamed it and called it auditing using data, or a method to obtain more accurate evidence. Few would argue the quality and quantity of evidence is essential to all auditors. Since data analytics easily delivers a substantial improvement to both, maybe thinking more along these lines could make it seem a little bit more attractive. Now, we constantly hear that data analytics adds value, improves efficiency, and provides hidden insight. But what does that actually mean in plain English? Here is a very short animation to show one way that data analytics can add value. So the point I'm making here is that value is added simply by testing all transactions rather than relying on a random sample. But what if you were asked to test all 2,000 transactions? The time taken could never be justified. But by using data analytics, in theory, you could do this in just seconds. There's your improved efficiency. Once you have completed one test using data, it is very difficult to stop there. You start to ask more questions, conduct more tests, giving you information you probably didn't even consider at the start. This is the concept of hidden insight, something that sample testing just cannot deliver. Now, the next hidden truth is related in unrealistic expectations. So this diagram shows you some of the common breakdown of skills usually needed to successfully apply data analytics. Now, the first box shows the human capability. This includes the knowledge of how to interrogate data, understand the results, and the onward communication. The next is behavior traits, which is sometimes described as the mindset of a data analyst. The final box is the technical capability. Now, this covers the knowledge of data software tools, just like Idea. The human capability is often gained in two ways. The first is through dedicated training or a relevant background. The other is through initial training and then a continued learning through trial and error. Essentially, you learn as you experiment. I think somebody mentioned that today. The behaviour traits can also be learnt, and many are qualities auditors already hold. They include curiosity, being sceptical, the ability to spot patterns, and the important one is to not be afraid to fail. The technical capability can also be developed through dedicated software training. So, as you can see, much of these skills can be learnt, but the problem is what is shown on this slide is not always properly understood. As a result, some have unrealistic expectations on what is possible. I hope this diagram helps to reassure those who have been put in the unfair position of attending a one-day training course and then expected to churn out some sophisticated data analytics the very next day. Oh, and train the rest of the team while they're at it. The truth is there is no silver bullet to developing these skills. It is definitely possible, but it will take time. So we discussed what these skills look like for an individual, but what work conditions could help improve your chances of success? Sadly, the culture of some audit teams isn't always compatible. Here are some work conditions which can be helpful. So firstly, it's where experimentation is openly encouraged and supported. This is really important because it takes quite a lot of trial and error to get the right results. Next, failure is accepted as learning. This encourages people to keep trying. A flexible audit process. This accounts for the highly unpredictable nature of data analytics. Next is where on-the-job training is reflected into work plans to ensure that the learning actually happens alongside delivering. And finally, audit leaders are creating strong motivating factors to encourage ongoing learning. Now, I accept it is not an easy task to change an entire team's culture. However, at least having this knowledge can start to generate some discussion. Now, the last hidden truth is the source of motivation. The truth is it takes effort to learn these skills. Now, some of us are lucky to have a strong natural desire, but others need an external factor to push them forward. Pay rises, fear of replacement, or new regulations are some sources of motivation. Without it, what is the reason to keep trying? For those of you who have audit qualifications, think about what motivated you to study so hard to ensure that you got over the finish line. If the status quo is good enough, it is easy to give up when the learning gets hard. One challenge is some audit leaders are not prioritising this area of learning at work. So, is this a mistake? You'd be hard pressed to find any major organisation who doesn't rely on technology. Many are using data to make business decisions. Some are even establishing data science teams, public sector included. If auditors aren't at least using basic data analytics, surely it's only a matter of time until clients start to wonder, why not? Right, I'd briefly like to pause there just to see if any of this is resonating with anybody in the room. So I'd appreciate, not leaving me hanging, if you could show some hands. So who agrees that the use of unexplained technical jargon can discourage beginners? Whoa, that's a lot. Okay. Who agrees that some audit leaders have unrealistic expectations from beginners? Who believes that the team culture does not always support skills development? Not so much, okay. And who believes that without a strong source of motivation, it's easy to give up quickly? That's all right, not too bad. Thank you. Okay, so moving swiftly on. The next section is what is data literacy and why is it so important? Following on from TSB's introduction there. Right, the term, has anybody heard of the term data literacy? No? Anyone? Right, 3, okay, right. So the term data literacy is often used in conjunction with data analytics. So one of its definitions is the ability to read, work, challenge, analyse and communicate data. Now, if we go back to the original skills breakdown slide, you can see that data literacy essentially covers the human capability. It is fundamental to data analytics and it is the human element which enables us to turn stored data into something meaningful. It's sometimes referred to as speaking the language of data, suggesting it's a learnt skill rather than something that just occurs naturally. Think about it like this. If you couldn't read or write, could you generate an audit report? A lack of data literacy creates the exact same restrictions in data analytics. Now, for those of you already applying these skills, you may not even have considered, why is it that you're able to apply data analytics, but the person sitting next to you just can't? Now, part of the reason is down to differing levels of data literacy. I'd like to try to explain it a bit more by breaking down the definition. So let's look at the first part of the definition, the ability to read and challenge data. This essentially is to understand the meaning behind the results of data analytics. So we're going to do a really quick example to demonstrate the point. So let's say that you're in London and you need to decide if you should have a barbecue today between 2 and 8. Essentially, this is the information you've been presented to make your decision. Does anybody want to have a go, be brave, have a go at suggesting what questions spring to mind if you were just given that to make the decision about having a barbecue between 2 and 8? Any suggestions?
Where do you live?
What do you mean, where do you live?
I'm in Edinburgh, so the weather in London means nothing to me.
Right, that's a good start. Okay, any more? This is all you've got. Should you have a barbecue? Is everyone that hungry? Okay, what does it mean? It's a good question.
Can you break it down into small
Is it even weather for the day?
That could be the night.
Okay,
Or in the
right.
sense of like, is it this day? Like, is it a weather for Sunday and I'm having barbecue on Saturday?
That is a question, right? Yep. Any more for any more?
Is the barbecue undercover?
True. It's another question.
In London, do you have a garden?
I know you've got a little tiny terrace, that's it.
Indoor barbecue.
Okay, I know everyone's hungry, so I came up with a few myself, so I think a few of them have been covered. So does the data relate to today? It doesn't say the date on there. There's no label that says it's London. It could be anywhere. What assumptions have been made to create these symbols? We don't know. How has that 60% been decided on? Was it guesswork? Was it an algorithm? Was it human guesswork? How reliable is the information that we've got here? What source is it from? Is it reliable? Did somebody just make it up from nowhere? We don't know what time that 60% trust relates to, so it could be in the morning, could be in the afternoon. Essentially, there are a whole load of questions that you can make, but the crux of it is, I couldn't make a decision based on what I'm seeing there, and that's essentially what I'm trying to say. So this slide here just gives you a few categories of how you can question when you see statistics. So you can kind of look at so what is the context? Is it accurate, like I said? Is it reliable? Can you have trust in the data that you're seeing? Are there any gaps? Do you need more information to make the decision that you need? Can you take action based on just what you've seen? And is it acceptable? Does it feel right? If the weather said it's going to be 100 degrees in December, that just wouldn't feel right. So there's just 6 little categories you can use to query data. The point I'm making is just simply presenting pretty stats and data visualization is not much good if A, it's completely misinterpreted, and B, it doesn't lead to some action. So as I said, a trick is, if you felt that looking at that diagram, not many questions came to mind, that may be a sign that you need to work on your data literacy, and just thinking about looking at data and querying it, looking at those categories can be a way to practice. So now let's focus on the next part of data literacy, to analyze data. Now this is the ability to select and perform the correct operation to obtain the information that you need. So going back to the scale of data analytics, again at the far end we've got complex algorithms which lead to future predictions. But if you're at the beginning of your journey, you can comfortably operate at the beginning of the scale using some really simple techniques. So the first one is comparison. So this is where you literally compare one data field with another to see if it's the same, different, or to calculate new values. This can help spot anomalies or even confirm that a control is actually working. The next is trends, where essentially you are identifying patterns which could be occurring in the business. So you're looking at whether volumes are going up, down, or are happening in unusual ways. Another method is to calculate the average. So that could be looking at the mean, the median, or the mode, and you can see how your population is spread and also whether there are some strange occurrences going on. You can also use it for benchmarking. The last part of the definition is to communicate the results of data analytics. As I said, communication is key to ensure that the information you're presented is interpreted in the right way. So here are some tips. The first is to frame your data results in the business story. So this is about setting the context in terms that the business will actually understand. It may sound cheesy, but storytelling in a business setting is a powerful way to influence change. Stories are one of the easiest ways that humans interpret information. So when you have some stats, try to weave them in to the way the business operates and talk about anything that's relevant at the time. The next is to understand your audience. There is a risk that their data literacy could be quite low, so you may have to explain statistics much more than if they have very high data literacy. Next is simplicity. Avoid jargon and technical stats which just don't add much. And the last one is about visualization. So using charts, graphs, pie charts and color, or even animation to improve your communication. The final section on data literacy, I'd like to share some content that I created on LinkedIn recently. So I wrote an article called Let's Talk About Data Imposter Syndrome, and it describes the fear that some people feel when those around them are talking about data analytics. This is made even worse by especially senior people, where there is the assumption they just know what everybody's talking about. Silence is taken as understood in many cases. So I asked people to tell them what the whole topic of data made them feel, and I created a word cloud to summarize the key themes. So as you can see, fear, embarrassed, worry and confused alone are some of the common terms that people used. I think it's just quite powerful just to look at what that diagram represents. That is the primary emotions that some people feel when they think about data analytics. I personally think there's an element of fear that is holding some auditors back from embracing data, and I think this goes some way to proving my point. So in the final section, just before lunch, I'm just going to walk you through some audit examples to demonstrate some simple yet practical ways that you can use data to help make much better assurance decisions. So the first example is, so the aim is to check that staff have adhered to their order approval limits for the 2,000 orders raised during the last 12 months. Now, selecting a random sample would only give you a snapshot of what is going on here. The data method you could use to check the whole population include field comparison, so like I said, checking one field against another, and calculation, using a simple formula to create new information. So how could you use IDEA? You could join the procurement data with the staff approval limits by matching the two fields together based on employee ID. This will give you access to both the order value and approval limit for each order. You can then use criteria to calculate if the approval limit exceeds the total order value, essentially subtracting one value from the other. So what could you discover? You could discover the total number of staff approving orders beyond their limits, or even identify if the breaches relate to a specific type of order. You could tell your client that 80%, that's 1,600 out of 2,000 orders, breach their approval limits. This could indicate poor control in the management of order approvals. I can't see how random sampling could provide you with that level of clarity. The second example, here we aim to check that the majority of suppliers have been paid within their stated payment period over the last 12 months. So the data methods you could use include field comparisons, calculations, and trends, essentially looking for patterns in the occurrences that you're reviewing. How could you use IDEA? You could join the supplier data, including the payment terms, with the paid invoice data, matching the two files on supplier ID. You could then append a numeric field to calculate if the invoice was actually paid on time, simply subtracting the expected pay date from the invoice pay date. You could see if it was a positive value, the order was paid on time. If it was negative, it was late. Then you could use visualization to display the pattern of performance across the 12 months. What could you discover? The total number of invoices paid outside the supplier payment terms, and you could identify if there were any common suppliers that were affected. You could tell your client that 1.5% of suppliers are paid outside the payment terms. Now, depending on the organisation, this could be viewed as a strong performance, indicating a low risk of reputational damage due to late payment. Once again, how would sample testing give you that level of clarity? So the final example is, we aim to identify if there are any unusual payroll transactions made to leavers in the last 12 months. Again, you could use comparison or summarization, which is about creating an aggregated total from a particular record. You could join the payroll and the leavers data to extract those employees who would actually receive payments. You could then summarize the number of payments made to each lever, and append a numeric field to calculate the number of months they were employed. Now, why are these two bits of information helpful? Well, as an example, if somebody had been only employed for 3 months, but they had received 10 individual payments, that could be seen as an exception. And that is exactly what you're looking for, these kinds of exceptions. You could then use criteria to check the entire population to identify more of these exceptions. You could discover the total number of leavers who had received more payments than they were entitled to, and how much each of these individuals were paid. You could tell your client that 25 leavers had received unusual salary payments, potentially indicating a control issue. Now, I accept there are lots of caveats in these examples, but I believe simplicity is the best way to demonstrate a point. It's difficult to argue. How could you obtain this level of insight I've just described by simply conducting sample testing? Even with some really simple techniques, you can see that you can get some really powerful information. So to close and to make way for lunch, we have covered some of the hidden truths to data analytics, unrealistic expectations, ambiguous language, conditions to succeed, and the source of motivation. We've covered data literacy in terms of understanding data, analysing data, and communicating data. And we've quickly walked through some examples that demonstrate how you can audit using data. Thank you for listening. Are there any questions? Thank you. Thank you.